In this video, I'm gonna tell you the differences between order and molecularity of a reaction. The definition of order is the sum of powers of the concentration of the reactants in the rate law expression is called the order of the chemical reaction. The definition of molecularity is the number of reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about chemical reaction is called molecularity of a reaction. Let us consider a general chemical reaction. AA plus BB gives CC plus DD. Here the rate of the reaction is K concentration of A to the power X, concentration of B to the power Y. Here the order of this reaction is X plus Y and the molecularity of this reaction is A plus B, small a plus small b, where small a is the number of molecules of the first reactant species A and the small b is the number of molecules of the second reactant species B. The order of a reaction can be 0. If it is 0, then it will be called a zero order reaction. If it is 1, it will be called first order reaction, and so on. And it can be also a fraction. But in case of molecularity, it can neither be 0 nor a fraction. The order of a reaction is experimental value and is derived from rate expression. But the molecularity is theoretical value and is derived from mechanism. Let's see some example. Calculate the overall order of a reaction which has the rate expression. In the first rate expression, the power of the first reactant species is half and the power of the second reactant species is 3/2. Then the order will be half plus 3/2 is equal to 2. Then it will be called a second order reaction. Similarly, in the second rate expression, the power of the first reactant species is 3/2 and the second reactant species is -1. Then the order will be 3/2 plus -1 is equal to 3/2 minus 1. Then it will be half. So the order of the reaction will be half order. Count the molecularity. Calculate the molecularity of these two reactions. Now see the molecularity of these two reactions. Here nitric oxide, 1 mole of nitric oxide reacts with 1 mole of ozone to give 1 mole of nitrogen dioxide and 1 mole of oxygen. Here the reactant species are nitric oxide and ozone. Nitric oxide is also of 1 mole and ozone is also of 1 mole. So the molecularity will be 1 plus 1 equal to 2. That is, it will be a bimolecular reaction. Then see the next reaction. Here nitric oxide have 2 moles and oxygen has 1 mole. So the molecularity will be 2 plus 1 equal to 3. That is, it will be a trimolecular reaction.